Welcome, everybody. So today we're going to talk about conductors. And to start us off, I want to talk a little bit about two different kinds of materials. And you're probably familiar with these different materials, but we're going to try to put some more precise physics language on them. The different materials are conductors and insulators. That's pretty much all we're going to talk about in this course. Now, conductors are objects which are typically metals that have a bunch of free charges that live inside them that can respond and move around in an external electric field. Insulators are the opposite. They don't have any free charges. All the little charges that live inside of an insulator are kind of bound up in individual atoms and they can't go anywhere. But conductors, they can move around, they can rearrange themselves. And so when I put an electric field on these different objects, we're going to get different physical responses. Now, for most of this course, we're not going to care much about insulators because they don't really do anything interesting. But conductors do really interesting things when we put electric fields on them. So we're going to try to explore them a little bit. I've drawn a picture of a conductor for us. It's just a big gray metal sphere in the middle of the screen. And I'm going to put a big electric field on it, which is indicated by these blue arrows. Now, I hope you had a little bit of fun with the Benjamin Franklin video because we're going to try to rely on some observations that we made there, which is that we kind of saw that there's some sort of shielding effect that happens where if I put a charge at the middle of this conductor, it shouldn't really do anything. That's kind of what we saw. But to do that, I'm going to need some additional electric field in there, right? I've got this external electric field that's upward, but there's not really a net electric field in the middle of this piece of metal, or all the charges would be going haywire. So basically what I can do is I can move the charges around so that the charges in the piece of metal itself kind of arrange themselves to cancel out this electric field in the region inside. And the way that you can get that is a bunch of positive charges up near the top, a bunch of negative charges down near the bottom. And you can see that positive charges create an electric field that way. The negative charges also create an electric field that way. So you get a net electric field from the piece of metal that points downward, cancels out the external electric field. And now all the other charges that live inside of the metal don't have a net electric field, and so they're happy to stay put and they'll stop moving. This process, by the way, if you have a neutral piece of metal and you stick it in an electric field, happens very quickly. It's like femtoseconds or something like that. It's an absurdly small amount of time that it actually takes for the charges to rearrange themselves, and then they hit this kind of static equilibrium configuration where they're all canceling out the internal electric field.